waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
This is the video for 8.1, finding angle measures in polygons. I'm going to review what a polygon is. It's a closed plane figure with 3 or more line segments called sides. Each side needs to intersect exactly 2 sides, one at each endpoint, so that no 2 sides with a common endpoint are collinear. So an example of a polygon would be something like that. So this polygon has 4 vertices and 4 sides. It is a convex polygon. And the reason I know it's a convex polygon is because if I were to highlight any side of this polygon, when I make my highlighter mark, the highlighter does not go through the middle of the polygon, okay? The highlighter does not go through the middle of the polygon. If I were to draw a polygon like this, then when I highlight the sides, like this side here, if I extend that highlighter out, you see how that highlighter goes through the polygon? That means that that polygon is concave. So you need to know the difference between convex and concave. A diagonal in a polygon is a segment that joins 2 non-consecutive vertices. So here is a polygon. A diagonal, for example, would be from here to here. Why? Because these vertices are not consecutive, meaning next to each other. Another diagonal could be from here to here, okay, or here to here, or here to here. So in this example, there is a diagonal from this vertex. There are 3 diagonals, 1, 2, 3. Okay, so in different polygons, the diagonals are going to look differently. You need to get out of your head that this is the only thing that is a diagonal. Yes, that is a diagonal because these are not consecutive vertices, but in a polygon with more sides, it looks different. The polygon interior angles theorem says that the sum of the measures of the interior angles of a convex, so that's why you need to know the difference between convex and concave, n-gon is 180 times n minus 2. N is the number of sides in the polygon. So an n-gon means a polygon with n number of sides. So if it's a 12-sided polygon, it's a 12-gon. Okay, we know that, for example, an octagon is 8-sided, so that would be 8-gon, but we don't use 8-gon, we use octagon. Okay, at the end of this video, I will review with you the names of the polygons. So the sum of the measures of the interior angles is 180 times n minus 2. So let's do an octagon. So what is the sum of the interior angles? Let me try to draw an octagon here. All right, so there is my octagon. It has 8 sides. And so in order to find the measure of these angles, add it up, okay? So the sum of these angles. They're not necessarily all the same. If it's a regular octagon, then they would all be congruent, okay? But they're not necessarily all congruent. But I can find the sum, and that's, I just plug into this formula. 180 times 8, because it's an octagon, it has 8 sides. So in other words, 180 times 6, which is equal to 1,080. So the sum of the interior angles in this octagon, or any octagon is going to be 1,080 degrees. So if I know 7 of the angles, I can find the 8th. Or if I know that all of them are congruent, I can find how much one angle is. The exterior angles theorem says that the sum of the measures of the exterior angles of a convex polygon, where there's one angle at each vertex, is 360 degrees. So I'm going to draw a pentagon. All right, so this is a 5-sided figure, and I'm going to show you what the exterior angles are. So I'm going to extend, there's only one exterior angle at each vertex. So at this vertex, I'm going to extend this line out, and this is one of my exterior angles. That's number 1. And then I'm going to extend this side out, and my second exterior angle is this guy. Then I'll extend this out. This is number 3. Over here is number 4. And finally, here is number 5. So the sum of angles 1, 2, 3, 4, and 5 is equal to 360. Again, not necessarily congruent, only if the polygon is a regular polygon. And that is true for every polygon. Now I'm going to do a couple of problems that relate to these theorems. The sum of the measures of the interior angles of a convex polygon is 900 degrees. How many sides does the polygon have? I know that the sum of the interior angles of a polygon is 180 times the number of sides of the polygon minus 2. So normally I would be plugging in the number of sides for n, but I don't know n. But I do know what the sum is. The sum is 900, so it means that is equal to 900. So now I'm just solving an algebra problem. I want to distribute first. 180 times n is 180n, minus 180 times 2 is minus 360, equals 900. Add 360 to both sides. 180n equals 1260. Divide by 180. N equals 7. So that would be a 7-sided polygon, which is a septagon or a heptagon. And I just want to remind you that these polygons don't all look the same. Not all septagons look the same. Not all hexagons look the same. So don't get in your head that it looks a certain way. Just understand that it means it has a certain number of sides. Now in this problem, I have a polygon. It has 5 sides, so this is a pentagon. It's not a regular pentagon by any means, but it's a pentagon. And I need to find the measures of angles D and E. Well, I know I can find the sum of the interior angles. So I have 3 of the angles. These 2 angles are shown to be congruent. So if I called this X, then this would also be X. So if I add up all of the interior angles, that is going to be equal to 180 times n, which is 5, minus 2. Where did I get the 5? I got the 5 because it's a pentagon. So now I need to do a bunch of math here to be able to figure this out. So I added up these constants on the left side, and I got 334 plus 2x equals 540. The 540 is because 5 minus 2 is 3, and 3 times 180 is 540. So now I'm going to subtract 334 from both sides. So 2x equals 206. Divide by 2 on both sides. X equals 103. So both of these angles are 103 degrees. Now, I just want to talk about the exterior angles really quick. So remember, the exterior angle is formed from extending out this side. So this is the exterior angle right here. So how do I find the exterior angle? Well, the interior angle and the exterior angle form a linear pair. So this is going to be 77 degrees because 103 plus 77 is 180. So the exterior angle and the interior angle form a linear pair. That's how you know that that's the exterior angle. All right, last thing is I just am going to leave for you here the names of the polygons that you need to know. So those are the names of the polygons that you need to know. You've already been introduced to them and should know them, but that's just your reminder.